Okay, good morning to all. So this is a continuation of the yesterday topic, that is chemical properties of the chemical chemical properties of chemical properties of amines. Yesterday we finished about the reaction with HNO2. Reaction with HNO2. Once again I repeat it. Reaction with HNO2, nitrous acid. Reaction with HNO2, nitrous acid. Amines react with HNO2 reacts with HNO2 at 0 to 5 degrees centigrade, gives diazonium salts. Diazonium salts. This reaction is called diazotization. Diazotization reaction. Diazotization reaction. Okay, now see the general example. RnH2 gives HNO2 in presence of HNO2 and 0 to 5 degrees centigrade or 273 degrees Kelvin to 278 degrees Kelvin. It gives Rn2 plus. Rn2 plus. This is called a diazonium salt. If I take R is equal to, if I take R is equal to methyl group, then CH3 NH2, CH3 NH2 in presence of HNO2 to 0 to 5 degrees centigrade, 273 degrees Kelvin to 278 degrees Kelvin, it gives a CH3 N2 plus. CH3 N2 plus. If R is equal to benzene, that is a phenyl ring. If R is equal to C6H5, then C6H5NH2. Nothing but aniline. C6H5 is nothing but aniline. So we can write like this: NH2. NH2 and NaNO2 plus HCl or HNO2 or HNO2 0 to 5 degrees centigrade. 0 to 5 degrees centigrade, we have the benzene diazonium chloride N2 plus and Cl minus. So this is a reaction with HNO2. So particularly this reaction was given by scientist name is Sand-Meyer reaction. Preparation of the benzene diazonium chloride. The condition is NaNO2 plus HCl or HNO2 0 to 5 degrees centigrade. Usually primary aliphatic amines or secondary aliphatic. Okay. Uh, primary aliphatic amines, and primary aromatic amines. Primary aromatic amines gives this reaction. Only primary aliphatic amines and primary aromatic amines gives the reaction, that is a reaction with HNO2 or NaNO2 plus HCl at 0 to 5 degrees centigrade. Usually alkyl diazonium salts are very unstable, very unstable, and phenyl diazonium salt, nothing but a benzene diazonium chloride, is a little bit stable at 0 to 5 degrees centigrade. This is one of the intermediate intermediate reactant, that is intermediate product. That product can be converted into different stable products using by different reaction conditions. when we get the different products. That is a primary and primary aliphatic amines and primary aromatic amines gives this reaction. Secondary and tertiary doesn't give this reaction. That is a reaction with HNO2. Next one is carbylamine reaction. Carbylamine reaction. Carbylamine reaction. Carbylamine reaction. Carbylamine reaction. Primary aliphatic and aromatic. Primary aliphatic and aromatic amines react with primary aliphatic or aromatic amines react with alcoholic potassium hydroxide in presence of the chloroform. Chloroform plus alcoholic potash, it is also called chloroform plus alcoholic potash, gives isocianides. Okay, now after formation of isocianides, after formation of isocianides, it gives a foul smell, otherwise a bad smell. Isocianides can be the foul smell or a bad smell. This is one of the identification test for the primary aliphatic and aromatic amines. Primary aliphatic and aromatic amines react with alcoholic KOH and chloroform gives isocianides. These isocianides contain the foul smell or a bad smell, so that we can determine the primary aliphatic and aromatic amines. See the reaction RNH2 primary amine plus alcoholic KOH by chloroform gives R bond NC isocyanide. This is a fundamental reaction. Okay, now if R is equal to any alkyl like a methylamine, otherwise a methanamine, plus alcoholic KOH by chloroform, it gives CH3NC. Methyl carbylamine, otherwise methyl isocyanide. Methyl isocyanide, or the IUPAC's name is methyl carbylamine. This is a IUPAC's name. This is a common name. Methyl isocyanide is a common name. Methyl carbylamine is a IUPAC name. So if R is equal to benzene. If R is equal to benzene, that is a phenyl ring. Benzene contain the NH2, that is called the aniline. Aniline plus alcoholic KOH by chloroform, it gives a phenyl isocyanide. So this is called the phenyl isocyanide. Or phenyl carbylamine. The IUPAC's name is phenyl carbylamine. amine. So isocyanates contain the bad smell or foul smell, so that we can determine the given organic compound contain the primary amine group. That primary amine group may be a aliphatic or may be a aromatic. So this is one of the reaction of the amines. Next, reaction with aryl sulfonyl chlorides. Reaction with aryl sulfonyl chloride, or reaction with aryl sulfonyl chloride, or reaction with benzene sulfonyl chloride. Aryl nothing but I take here benzene. So reaction with benzene sulfonyl chloride. This reaction is used to distinguish the primary, secondary, and tertiary amines. This reaction is used to distinguish the primary, secondary, and tertiary amines. This reaction is used to distinguish the primary, secondary, and tertiary amines. So now see the reactions of this primary, secondary, and tertiary amines can be differentiated by this reaction. Let us take primary amine RNH2 plus benzene sulfonyl chloride SO2Cl, benzene sulfonyl chloride. So it lose HCl minus HCl, then RNH SO2 benzene, N alkyl benzene sulfonamide, N-alkyl benzene sulfonamide is a name of the compound. If R is equal to simple methyl group RNH, okay, CH3NH2 plus ClSO2, so I am writing like this, ClSO2 benzene sulfonyl chloride, remove the HCl, minus HCl, it gives a CH3, NH, SO2 and benzene. Name of the compound is N-methyl benzene sulfonamide. N-methyl benzene sulfonamide. N-methyl benzene sulfonamide. If I take N is equal to phenyl, here also phenyl, that is aniline. What we get here? Aniline. That is equal. R is equal to phenyl, then you will get the aniline. Aniline plus benzene sulfonyl chloride. Benzene sulfonyl chloride lose HCl. Here N-phenyl benzene sulfonamide. The compound is NH, SO2 and benzene. So name of the compound is N-phenyl benzene sulfonamide. This is a reactions of primary amines with benzene sulfonyl chloride. Girls, is it clear, Amma? Are you listening me? Okay, now see here primary amines, either aliphatic amines or aromatic amines react with benzene sulfonyl chloride. It gives a corresponding product, that is N-alkyl benzene sulfonamide. Right here, alkyl group may be a okay, no, okay, no. Alkyl group nothing but a aliphatic, otherwise aliphatic alkyl group, or we can take aromatic alkyl group, that is aryl groups. So if it is aryl, nothing but we have the aniline. So N-phenyl benzene sulfonamide, and here N-methyl benzene sulfonamide. So these N-alkyl benzene sulfonamides are dissolved in alkalis. That is a point here. The conclusion is N-alkyl N-alkyl benzene sulfonamide, N-alkyl benzene sulfonamides dissolved in strong bases. Dissolved in sulfonamides are dissolved dissolved in alkalis. Alkalis nothing but a strong basis of first A group and second A group basis. Okay, now next one, secondary amines. Secondary amines also react with benzene sulfonamide, benzene sulfonyl chloride. It gives NN dialkyl benzene sulfonamide. NN dialkyl benzene sulfonamide. NN dialkyl benzene sulfonamide does not dissolve in the bases. Yes, listen. Secondary amines, either aliphatic or aromatic. Either aliphatic or aromatic. Either aliphatic or aromatic secondary amines react with the benzene sulfonyl chloride, gives NN dialkyl benzene sulfonamide. This NN dialkyl benzene sulfonamide does not dissolve in alkalis. See the reaction R NHR. This is secondary amine. Secondary amine plus ClSO2 benzene. This is a benzene sulfonyl chloride. Benzene sulfonyl chloride. It lose one molecule of HCl from two molecules. Just this hydrogen and a chlorine. Hydrogen and chlorine get removed. So then NN dialkyl. NN dialkyl. So here R N R SO2 benzene. N R SO2. Okay, now. Yeah, right. This is called N, N dialkyl, NN dialkyl benzene, NN dialkyl benzene sulfonamide. NN dialkyl benzene sulfonamide. If I take R is equal to methyl groups, or R is equal to phenyl. So first take the methyl CH3 NHCH3 plus ClSO2 say 6H5 minus HCl, it gives CH3NCH3 SO2 benzene. So this is NN dimethyl, NN dimethyl benzene sulfonamide. NN dimethyl benzene sulfonamide. If N is equal to R is equal to phenyl, that is aryl groups. then C6H5, NHC6H5. Nothing but these two are the phenyl rings. If you have confusion, directly you can take the figure of benzene like this. Benzene, NH and benzene. These two are the phenyl rings. This is secondary amine plus SO2 benzene. That is benzene sulfonyl chloride. Benzene sulfonyl chloride. Remove HCl minus HCl minus HCl. Got it, Amma? Girls, is it clear to all? Are you listening me or? Now see here. Minus, remove the HCl, then NN diphenyl benzene sulfonamide chloride you will get. NN diphenyl. SO2 benzene. So name of the compound is NN diphenyl, NN diphenyl benzene sulfonamide, benzene sulfonamide. So this NN diphenyl benzene sulfonamide does not dissolve in alkalis. NN diphenyl benzene sulfonamide or NN dimethyl benzene sulfonamide or NN dialkyl benzene sulfonamide does not dissolve in alkalis. And the last one is tertiary amines R and R plus benzene sulfonyl chloride, no reaction because your hydrogen is not available. Hydrogen is not available. Therefore, primary amines, secondary amines, primary amines, secondary amines, and tertiary amines can be distinguished from the reagent benzene sulfonyl chloride. So this benzene sulfonyl chloride reagent is called the Hinsberg reagent. Hinsberg's reagent. So using by the Hinsberg reagent, we can differentiate the primary, secondary, and tertiary amines. Is it clear, Amma? Primary amines can form the N-alkyl benzene sulfonyl chloride, sulfonamide, and the secondary amines can form the NN dialkyl benzene sulfonamide. First one is dissolved in alkalis, second one is unable to dissolve in alkalis, and the third one doesn't react with the benzene sulfonyl chloride. So the primary amines and secondary amines and the tertiary amines can be differentiated using by the reagent benzene sulfonyl chloride. That reagent is called the Hinsberg reagent. Is it clear, girls? Is it clear to all? Girls? So just now what we discussed about the carbylamine test, that is also called the carbylamine reaction. Primary amines of the aliphatic and aromatic react with the chloroform and alkalic potash. It can form a foul smell or bad smell compound. That compound is called the isocyanates, phenyl iso. That also identification. That is identification of the primary amines. It may be a aliphatic or a aromatic. But this is differentiate the primary, secondary, and tertiary amines from the mixture of the amines. Primary amines react with Hinsberg reagent, gives N-alkyl benzene sulfonamide that is dissolved in the alkali. Secondary amine react with Hinsberg reagent, it gives NN dialkyl benzene sulfonamide, it does not dissolve in alkali. Third tertiary amine does not react with Hinsberg reagent or benzene sulfonyl chloride. Therefore, we can distinct the primary, secondary, and the tertiary amines. Clear amounts? Shall we go to the next topic? Okay. Next, till now what we discussed the nucleophilic substitution reactions of the primary, secondary, and tertiary amines. In that, basicity is there, alkylation, acylation, benzylation, reaction with the HNO2, okay, now reaction with the chloroform and potassium hydroxide, and the reaction with the Hinsberg reagent. So these all are the example for the nucleophilic substitution reactions. Now we are going to the electrophilic substitution reactions in amines, particularly for the aromatic amines. So electrophilic substitution reactions, electrophilic substitution reactions of aromatic amines. So aromatic amines. So we can understand aromatic primary amine, aniline. Aniline is a primary amine. It is a aromatic primary amine. Aromatic primary amine. Aromatic primary amine. So it is commonly known as aniline. It contains the lone pair of electron. The NH2 contains the lone pair of electron. So this NH2 group is a electron donating group. Electron donating group. When EDZ, electron donating groups are EDZs are present on benzene, then the electrophile will direct towards, then the electrophile E plus will direct towards either ortho position or para position. So this is called the orientation of the benzene or ortho para directing groups. This is also called orientation of benzene. Orientation of the benzene or ortho para directing groups. So aniline, the benzene contains the NH2 group is electron donating group. Here we study about the electrophilic substitution reaction here, ortho and para positions. Ortho and para, the electrophile will direct towards the either ortho position or a para position. So in this case, first one, halogenation, we know electrophilic substitution reactions are 5 categories. So this already we discussed in the offline classes. 5 categories: halogenation, alkylation, acylation, sulfonation. Next one is a nitration. Total 5 aromatic electrophilic substitution reactions are there. In that category, first reaction is halogenation. That is particularly bromination. Bromination of aniline. That is aniline react with bromination of aniline. Aniline react with bromine water Aniline react with bromine water at a room temperature. React with bromine water at a room temperature gives 246 tribromo 246 tribromo aniline. 246 tribromo aniline. This is a white precipitate. This is a white precipitate. Here the electrophile is electrophile is bromonium ion. Here the electrophile is bromonium ion, that is Br plus. Br plus is an electrophile. So see the equation, aniline plus Br2 by H2O at room temperature, it gives 246 tribromo 246 tribromo aniline. This is a white precipitate. Is it clear? That is one of the electrophilic substitution reaction of the aniline, nothing but under the aromatic primary amine. Aromatic primary amine. Next. Next reaction is acylation. Acylation of the aniline. Acylation. Alanine reacts with acetic anhydride CH3CO taken twice to O, or acetyl chloride CH3 C double bond O Cl acetyl chloride, or ethyl acetate CH3COO CTH5 in presence of pyridine. In presence of pyridine gives N-acetyl anilines. N-acetyl anilines gives N-acetyl aniline, or it is also called the acetanilide. It is also called acetanilide. Is two of the common names, N-acetyl aniline or acetanilide, and IUPAC's name is N-methyl benzenamide. N-phenyl benzenamide. See the reaction. Reaction is of aniline in presence of the acetic anhydride CH3CO taken twice to O and pyridine. It gives a N-acetyl, okay na, aniline. N-acetyl aniline. This is a common name. Otherwise acetanilide. Acetanilide also common name. IUPAC's name is, the IUPAC's name of this compound is CH3 C double bond O NH2, that is called the ethanamide. This is called the ethanamide. So that's why N-phenyl ethanamide is the IUPAC's name of the compound. IUPAC's name of the compound. If I use the, instead of the pyridine, NH2 plus acetic anhydride in presence of AlCl3, Lewis base, AlCl3, acetyl group is substituted at either ortho position or a para position. C double bond O CS3 ortho amino acetophenone plus para amino acetophenone. Para amino acetophenone. This is a difference between acylation of the aniline in presence of the pyridine in presence of the AlCl3. If you use AlCl3, then you will get the electrophilic substitution on the benzene. But if you use the pyridine, so it will undergo the nucleophilic substitution. That is a so in place of hydrogen, acyl chloride is a acetyl group is substituted. So in this case, a major product is this one. This is a major product. This is minor product. Okay, now almost time is up. Right, almost time is up. Next class we will continue. Goodbye to one and all. Bye, Emma.